it just says Siberian warmth, and it has 6 graphs, temperature anomaly from December 2019 to May 2020, and it shows the Siberian region, what's going on. So how do we break this down?
Okay, I'm gonna get my orientation here.
Graphic.
It's really interesting. If you look at the graphs there, it appears that February and April show the warmest anomalies.
Right.
Really kind of interesting. And looking at this, let's see, that's Siberia. Okay, okay, there we go. Okay, that's the Arctic Ocean. There's Novaya Zemlya. Okay, that if you look towards like the upper left side there, you see like an outline of an island that's kind of very thin and long.
I think so. Yes.
That's a reference. I use it as a reference. That's like the Laptev Sea, whatever. But that's called Novaya Zemlya, which is literally Russian for New Earth. But
oh, wow.
so if you look at December, right off that island, you see where it's really, really hot.
Yes.
Okay, that's part of the Barents Sea, and there's some data now that's showing that the Barents Sea is becoming what they call Atlantified, that the physical parameters of that region is showing more in common with the Atlantic Ocean than with the Arctic Ocean.
Oh no.
So there's an infiltration of saltier water, but warmer water as well. And if you have a warmer water, that could, a little bit of extra heat from below might prevent ice from forming or not, or forming later or not as thick, etc. It's still going to give off its heat. And again, keeping in mind the lag, so December is going to be the autumn for the ocean. So we got a little bit of heat being given off there. So I think what this is showing is some Atlantic water infiltration into the Arctic Ocean. And you can see that, if you look over at eastern Siberia, it's either a little cooler, a little warmer, it's about average all across the region. And then in 1 month's time, looking at January, look what's going on. Especially a little further southern latitudes.
Jeez, I know.
Getting away from the coast, it's kind of really warm down there. But you can see the warming of the region.
Clearly, it's just red. And like you said, February and April, it's the darkest red. And that's concerning because isn't that in the winter in a way? Like,
March is typically would be the oceanic winter.
Okay.
So we're proceeding towards it. And that's what's interesting because, we're 2 months in, we're towards the winter there, and see how warm it is in February. It's just like crazy.
That's amazing. And that goes back to that bipolar polar we talked about in February.
Yeah.
Jeez.
Now, keep in mind, these are air temperatures. So when you go back to December, I was talking about Zemlya and Novaya, okay, that really warm spot there, off the island is probably some of the heat being given off by whatever the underlying water is at that one little spot that you might have like a little upwelling or something. Have to review the hydrogeography of it. But could then look in January, that what was very red is now very blue. Like it gave off its heat.
Yeah, it's like night and day. Jeez.
But it is just, right there into the, the Laptev seas and all that kind of stuff there. It's super warm. And that's going to prevent you got such warm air temperatures, that's going to, affect what sea ice you have.
And once again, thawing the permafrost, which we've gone over the consequences over and over again. Because this is a persisting issue. This heat wave is persistent, is the term I'm going to use.
It's been like this now for 6 months, and even though when you look at the land side of things, December, January, winter time, it's still, if the ground is, if the air temperature above the ground is that much warmer, it, when you get more sunlight and get more energy reaching the surface, the permafrost will then be in a position to thaw out more readily.
Jeez.
And that's what we're heading into now when you look at April and May, is you start increasing sunlight energy, and now you got the increasing warm temperatures, 38 degrees C, and
Sorry.
you're just going to really thaw things out. I'm wondering if they're taking measurements of what the methane release levels are. They probably are. I'd like to see that data.
And I remember last week you were talking about how the acceleration of climate change is happening because things were, right, we were projected to hit 3 to 5 degrees Celsius range. That's still kind of big from 80 years from now, but now it's more like 9 degrees Celsius. So things
that's what one study that just came out is reporting. Yeah.
Oh, wow. Jim, that is frightening. Okay, we're at like 1.3, 1.1. Yeah, it's
1.3, 1.4, yeah, something like that. I mean, yeah, I'm presenting that. You know, I'm editing it, whatever. You know, I'm presenting that. It's been peer reviewed. Now, some people might say it's at one extreme level. Okay, fair enough. If you take the midway point, it's still 5 degrees C. That's still disastrous.
mm-hmm.
2 degrees C will really accelerate melting of Greenland. So you hit even 3 or 5, Greenland will be almost ice gone. You know, so and with that comes a corresponding sea level rise, which then affects coastal cities, the Atlantic meridional overturn circulation, all these ripple effects.